Alright, this week we are writing algebraic expressions, and this is the quiz review. This will be number 7 in your notebook. Number 1, write an expression to represent the following. What we have is 2 less than the product of 7 and a number n. Earlier this week I gave you a list of words and what they mean. Now, you don't always know exactly what operation to perform or whatever. There's not always a key word, but a lot of times in these there are. Okay, so for example, we've talked about product, which means the answer of a multiplication problem. Less than, that's going to mean we subtracted and so on. Now what it says here is 2 less than 2 less than 2 less than something. If I said 2 less than 3, I would say 3 minus 2, because I'm saying 2 less than this. Okay, but I'm not doing that. I'm saying 2 less than the product of 7 and a number n. 7 and a number n, that basically means that we're talking about a variable. I'm saying 2 less than, so I'm going to go ahead and write minus 2 out here on the right side, because I know it's going to be 2 less than something else. So if I want to say 2 less than something, I say that number minus 2. Well, we don't have a number like we did up here. We had a 3 minus 2, but what we're having here is the product of, which means we're going to multiply 7 and a number n times n, like so. And we can also represent it the algebraic way, which is the way you need to. 7 times n is the same thing as we've been doing in class, 7n. And you can just say minus 2. And if you take a look at this again, and it makes perfect sense. 2 less than the product of 7 and a number n. 7n minus 2. Number 2, write an expression to represent the following. The number of stamps in Ethan's collection is 4 more than indicating addition. 4 more than what? Well, it's 4 more than half the number of stamps in Helen's collection. So what you're going to have to do is come up with your own variables here. We want an expression representing this situation. So it's going to say 4 more than. So we can say plus 4. 4 more than what? Half the number of stamps in Helen's collection. We don't know how many stamps is in Helen's collection. So why don't we represent her collection by the letter H? How do I say half of H? Well, I could either divide it by 2, but the easiest way is to say half. Half times that. We've learned about fractions before. Half times H plus 4. So again, let's read it again to make sure we understand. Write an expression to represent the following. The number of stamps in Ethan's collection. So basically, if we were writing an equation, this would say equals Ethan. We'll just say E, and forgive my bad handwriting. 4 more than, represented here, half the number of stamps in Helen's collection. 1/2 H. So she had 7, or sorry, so she had, let's say she had 400. We would say 1/2 times 400, represented here, plus 4. Okay. Number 3. Lucy babysat for 2 hours on Friday, 3 hours on Saturday, and 2.5 hours on Sunday. She earns D dollars per hour for babysitting, so it could be $7, it could be $20, we don't know. What they're asking you to do is write an expression to represent her total earnings for the 3 babysitting jobs. Well, we could do this several different ways. We could say she worked 2 hours, and then plus 3 hours, plus 2.5 hours. But we got to multiply all that by D, because that's the number of dollars she earns per hour. So we could do that this way. We say, put that guy in parentheses and put a D on the outside of this, which means D times all of this in here. And you would eventually add this up. You would say D, and this is 7.5. Or, I'm sorry, 7.5 D. So you could do it that way. Or you could say something like this. How many dollars an hour does she earn for 2 hours? 2D plus 3D plus 2.5D. And if we combine like terms, and we can combine all 3 of these, we would say 7.5D. 7.5 for the number of hours she worked times D for the number of, or for the dollars per hour she gets. Number 4. Write an expression to represent the following. Jason is K years old. Mia is twice as old as Jason. William is 3 years younger than Mia. Write an expression to represent William's age. William is 3 years younger than Mia, so let's say minus 3. Let's work this guy backwards. Well, 3 years younger than what? Well, Mia. Well, now you just need to find out how old Mia is. And it says here, Mia is twice as old as Jason. Jason is represented by what? K years. So we would say 2K minus 3 is the expression. So let's walk through this again. Jason is K years old. Mia is twice as old as Jason, which means 2 times that. So if Jason's 10 years old and Mia is twice as old, we would multiply by 2. And then we're going to say here, William is 3 years younger than Mia. Well, we know how old Mia is because Mia is 2 times K, which is 2 times Jason's age. William is 3 years younger than that, so we're going to say minus 3 here. And we're supposed to write an algebraic expression to represent this, and it's right here. Number 5 is a little easier. 83 less than a number n. When it says less than, and when it says a number n, that just means n. A number, and that means it's represented by n. So we would just say n minus 83. 83 less than. Anytime you see the words less than, that means that number minus 83, or that number minus 84, or whatever it is. Less than a number. 83 less than a number n. Number 6, let n stand for an unknown number. Write an expression representing the following. So we are given the variable here. Sometimes I'll let you make up your own variable. Sometimes it'll be given for you. The sum of a number. That usually means it's the variable. And 3 divided by 7. What that means is the sum of n and 3. What does sum mean? The sum of what? The sum of a number and 3 divided by 7. Or you could write it n plus 3 in parentheses divided by 7. Because it's all of this divided by 7, not just the 3. Because if you're not careful, you'll write n plus 3 divided by 7. And as you know, that's not the same thing, because that means this goes first. These two are completely different things. So you could write it either that way or that way. This one you really got to use your head on. Jason has S yards of string. For an art project, he can cut an equal number of pieces of string if each piece is 11/12 of a foot long. Write an expression showing the number of pieces he can cut. All right. It'd be S divided by 11/12. Because each piece we want to cut is just under a foot long. So if I had, for example, Jason has 5 yards of string. Actually, you know what? Again, this one's wrong. I want you to skip this one. Skip 7. Because I copied this one from the book. And the reason why, this is in yards and this is in feet, and I don't want to confuse you. So just forget number 7. We'll do another one like it. Forgive me. Or forgive the book. The Smith family stayed at a hotel for n nights. So it could be 5 nights, 4 nights, whatever. It's a variable. It's an unknown number of nights. The cost was $80 per night. So we have 80 n plus a one-time fee of $20 because they brought their dog. Write an expression representing the total cost of their stay. So this expression right here will give you for any number of nights that they stayed, will give you the cost. This fee of $20 was a one-time fee. They only had to pay it one time. They did not have to pay it every night. It said a one-time fee of $20 plus $80 a night. Now this is a perfect example of a linear expression where we have a constant here, which means no matter what, we're going to pay $20. It's kind of like the situation I've talked about in class. A plumber charges you, for example, $100 to come out to your house. No matter how much work he or she does, they're going to charge you $100 just to pull in the driveway, plus $50, $40 an hour or whatever. In this case, the one-time fee is $20. No matter how many nights you stay, you may stay one night, you may stay 50 nights, but you're going to pay that $20 fee once. And then for every additional night you stay, it's going to be $80. So in this case, we have the constant, which is a number by itself, the variable, and the coefficient, which is 80. The number of pledges, and what we're talking about is like a walkathon, the number of people who have agreed to do this. The number of pledges that Melissa collected for this year's charity walk is 8 less, and so we know we're going to say something minus 8, half the number of pledges she collected last year. So we're going to multiply 1/2 times something. She collected P pledges last year. So in this case, we're going to say 1/2 P. Write an expression representing the number of pledges she collected this year. Well, let's read it again. The number of pledges that Melissa collected this year, or for this year's charity walk, is 8 less than half the number of pledges she collected last year, which is represented here by P. So she collected 10, we would say 1/2 times 10 minus 8. Okay? 1/2 P minus 8. Aiden is shopping for school supplies. He has $35 to spend on a calculator and some notebooks. So he's going to buy a calculator and some notebooks. He will buy one calculator for $18. Let N represent the number or the cost of one notebook. Write an expression representing the number of notebooks Aiden can buy. Okay? So what we would have is this. Let's just say, for example, that you had $35 to spend, and you had to pay $18 for a calculator, and then whatever is left, basically, you could buy notebooks with. So we would say 35. Well, I got to spend 18, so I'll have that much less. Okay? And so whatever my answer is needs to be divided by N so I can see how many I can buy. So, for example, if notebooks were $1, I would basically say 35 minus 18 equals 17, and I would divide that by $1 to figure out that I can buy 17 notebooks. Okay? Well, in this case, it's not that simple because we've got to say 35 minus 18 divided by the cost, which is N. So if they were $2, we could buy however many. If there were $3 and so on and so forth. So you can say it one of two ways. That, or you could say 35 minus 18, which gives us a number left. Then with that money, I can buy that many notebooks. Or the cost. Okay, so let's look at this again. We have $35. We know we're going to have to spend 18. Then we divide that number by N, which is the cost of one notebook, to see how many notebooks we can buy. And you can represent that two ways. 35 minus 18 over N, or 35 minus 18 divided by N. Both of these mean the same thing, divided. Now keep in mind, 35 minus 18 divided by N, like this, is not the same. Because that means this. 35 minus all of this. What we're saying is all of this divided by N. A landscaper charges $30 for each job. So $30 just to show up, plus $20 an hour. This is the constant, this is the variable, this is the coefficient. A landscaper charges $30 for each job, no matter what. If it's just to come out to cut one bush or to cut 5 acres of grass, it's $30 plus an additional $20 multiplied by the number of hours. 20H plus 30. I'm going to go ahead and write the answer, then I will work from that. Dora found 6 less than 3 times the number of shells that Chris found. Let S represent the number of shells that Chris found. So instead of saying C, we're going to say S. Write an expression representing the number of shells that Dora found. Dora found 6 less than 3 times 3. Multiplication is indicated by 3 times the number of shells that Chris found. Let S represent the number of shells that Chris found. So we're going to bring this guy and put it in here. Dora found 6 less than 3 times the number of shells that Chris found. 3 times the number of, or 3 times S. Okay, there's your answer.